Hey everyone, welcome to the Intro to Chemistry video lesson. In this lesson, we're going to be going through some of our basic terminology that we'll be using through the whole semester in chemistry and really throughout the whole year as well. So the goal of this lesson is to be able to define chemistry and understand the scientific method. So to start off, giving you a basic definition of chemistry that really gives you a really good broad overview of what chemistry is chemistry is a science that deals with the materials of the universe on an atomic scale and the changes that these materials go through. So looking at this definition, I would really pull out three important words: materials, atomic scale, and changes. When it comes to materials and atomic scale, you should really be thinking about atoms and how atoms are specifically interacting with one another. In terms of changes, we're really going to be talking a lot about changes right away within our first unit. We're going to be looking at how is matter undergoing change and how are we observing that specific change as well. Okay, the scientific method. At this point in your educational career, I really expect you guys to be very familiar with the scientific method and definitely know the order of the steps. But just to give you guys a quick recap of reviewing what the scientific method is. Always first with the scientific method, you always start with making an observation. A lot of the times observations are used using your five senses, so different things that you can hear, taste, see, so on and so forth. And it's something that is witnessed and can be recorded. Off of your observations, you're then going to define a problem. And from this problem, you might formulate a lot of questions, and from your hypothesis and make a prediction on what you think is going to happen. A lot of times after you form your hypothesis and make a prediction, you're then going to design your experiment to test your hypothesis. The next step as you are running your experiment, you're going to be collecting data through experimentation, and we'll talk today about the different types of data that you can collect throughout a lab. Once you're done collecting your data, you then analyze your evidence. So analyze your data is your evidence. And then from there, you're going to form conclusions. And conclusions is always the last thing that you're going to do. The most important thing about forming conclusions is that it's always based on the evidence that we collected. So your conclusion is always based off of your data. So your conclusion should always be supported by some sort of data or evidence from the experiment that you ran. Okay. Down below is just a fun video from the Big Bang Theory. It basically just shows a clip from one of the seasons looking at them going through the scientific method. So go ahead and check that out. Okay, observations. So as you recall, observations is the first step of the scientific method. But what I really want to point out here is the difference between an observation and an inference. Because a lot of the times I see students getting the two terms kind of confused or using them irreversibly. As we mentioned before, an observation is something that is witnessed and can be recorded. So again, a lot of times it's something that you use with your five senses. So things that you can hear, taste, smell, so on and so forth. A lot of the times there are different things that we can measure in a lab as well. Whereas an inference, it's an interpretation. Right? So it's a possible explanation of why nature behaves in a particular way. And I would say key thing in that definition is it's an explanation. So looking at the picture that we have over to the right of the girl looking at the grasshopper, some observations that I could make is that the grasshopper is green. An example of an inference would be, well, since the grasshopper is green and has 1, 2, 3, 4, 5, 6 legs and 2 antennae, I can infer that it is a grasshopper. Okay, so just some key differences between the two. Okay. All right, qualitative versus quantitative. Okay, so key thing with quantitative versus qualitative is these are both different types of observations that we can make in and an experiment. How I really remember the two is looking at just at different terms within the words. So looking at the first one, quantitative. I think of quantity, or I think of numbers. Okay, so quantitative type of observation or quantitative type of data, it describes an amount or quality. Okay, so different examples is taking mass of an object, time, how much, volume, or etc. So a quantitative observation, looking at the picture below of the candy, is counting how many of the different candies are there, or taking the mass of each individual one. That would be quantitative. Okay, so I think of a number amount. Whereas qualitative, I think of quality. So I think of L for the quality as in language, so I use descriptive words. So it describes the physical makeup. So a lot of the times within qualitative observations, you're using non-numerical data in that. So looking at the picture, we can describe different things as soft or blue or round or rough. A lot of times in chemistry, we're not going to be tasting things, unfortunately, but we're still going to be making a lot of different types of qualitative observations. Okay, observation terms. Okay, so oops. Okay, so different types of observation terms. So these are just different types of qualitative terms that you can use within those observations. The first one is luster. So defining if something is shiny, we say something is lustrous. Next one, translucent, meaning that light can pass through, meaning you can see through something. So we say something is translucent, meaning it's see-through. Okay, we use this a lot of times in chemistry to describe different solutions. Opaque, on the other hand, is the opposite. So it's talking about light can't pass through, so you can't see through it. So an example of something opaque would be like milk. Something translucent that's a solution would be like water. To show you guys the two differences between those two terms. The last one, malleable, is something talking about that it's bendable and it can be hammered into a thin sheet without breaking. A lot of the times the term malleable is used in terms of when looking at different types of metals. Okay. Last part of these notes is looking at the difference between theories and a law. Now, key things, theories aren't inferences. And what a theory is it's a widely recognized and supported conclusion. Key thing about a theory is it's looking at why things are happening, why there's specific phenomena. And they're always supported by a vast number of observations. Okay, so key thing to remember about a theory is we're always looking at why stuff happens. And they're always going to be supported by a lot of experiments that back up that theory. Also supported by a vast number of people within the scientific community. And it's also going to be supported by a lot of data as well. That's kind of a key thing. And it's always going to explain why specific things are happening or occurring. Okay, and the last thing is theories don't become laws. What a natural law is it tells us what will happen, where a theory or a model is our attempt to explain why it happens. Okay, so key thing about a law is it tells us what will happen. For example, if I drop my pen, it will fall to the floor due to the law of gravity. So that's kind of the key difference between a theory and a law. A theory is always going to tell us why it happens, whereas a natural law tells us what will happen. Okay, so that is the end of the Intro to Chemistry notes. If you guys have any questions, feel free to leave them in the comments below, and I will see you in class.